In this video, we're going to talk about how do we write the formula and names of binary compounds, which is basically two elements that contains no metals. We all know that when you look at the formula or name of the compound, as soon as you can identify a metal element, then that means this is going to be a cation, or in other words, this is going to be a metal non-metal combination. Because usually metal will be only form positive charged cation and non-metal will form negative charged anion, so this will be an ionic compound. So that's how easily we can identify what type of compound this is. Okay. Now certainly for this reason you will never have metal combination because you can't have positive combination. Okay. So for any compounds, the overall charge has to be positive negative, so to be zero out the charge, but you can't have positive, so this will never work. But is it possible to have non-metal combination? And the answer is yes. Okay, so this will be, but they're not negative anymore. Okay, so when it comes to non-metal combination, they're gonna actually form covalent bond between non-metals, and so they're gonna form covalent compound. Okay, so here's what we're gonna discuss about this type of compound. So when you have two elements, they both are non-metals. Okay, if you don't know how to distinguish metals and non-metals, you go to the previous video to look it up on the periodic table. So when you have two elements, okay, they both are non-metals. Here's how we're gonna name them. Okay, you're gonna have a one element in front of the other element. You should not switch the order. Okay, so the first element, you're gonna pretend it to be a metal, so you can use its original name, elemental name. Okay. Now the second element, as you were the anion, which means you can use the IDE ending. Okay. And of course, in order to show the ratio between two elements or the numbers between two elements, you have to use some prefixes. Since there's no charge anymore, okay, so we have to specify the number in the name. Okay. And the prefix mono is never used for naming the first element, which I don't know what that means, but let's look at a few examples so it can be easily explained. Okay, so first of all, what do you mean by prefixes? Okay, now for instance, this compound PCl5. Okay, so when you have phosphorus and 5 chlorines, look like PCl5, which means there's no charge. Okay, because you know phosphorus is an anion. It's not an anion. It's non-metal. I'm sorry. Phosphorus is a non-metal. Chlorine is a non-metal. So this is a covalent compound. Okay, this is very important. Okay, this is not ionic compound because the reason is very simple. You have no metals. Okay, and there's no number in front of after phosphorus, so that means this is actually 1. Okay, so this is 1. Now you have to say, okay, phosphorus. Phosphorus is going to remain its original name, okay, but the chlorine, instead of chlorine, is going to say chloride, as it were the anion, okay. And now you have to show 1 to 5 since there's no charge, okay, so you have to put the prefixes. So these are the prefixes. Instead of saying 1, 2, 3, 4, 5, 6, and so on and so forth, we say mono, all right, for 1, di for 2, tri for 3, tetra, penta, hexa, hepta, octa, nona, deca, with its corresponding numbers. So the number after phosphorus is 1. Presumably we should put the mono in front of phosphorus. But the rule says, okay, the previous rule says you do not put the mono in front of the first element. So don't put the mono there. Now for the second element here, chloride, okay, you have 5 of them. So you're going to use the prefix penta. So the name of this compound will be phosphorus pentachloride. Okay, now let's look at the second one. This is sulfur and fluorine, so it's going to be 1 sulfur, again mono, but you don't say mono, you just say sulfur. Fluoride, but there are 6 of them. Okay, see 6 here, so you're going to use hexa. Okay, so it's going to be sulfur hexa fluoride, with ID ending. Right, so this is I'm sorry, PCl5. This is SFX6. SO2 is one sulfur again. Sulfur. All right. This is supposed to be 2 oxide, so you're gonna say dioxide instead of 2 oxide. So dioxide. It's gonna be SO2. All right. P4O6. Okay. Now this is phosphorus plus oxide, but there are 4 phosphorus, so you can't just ignore the number anymore. Okay, you have to show any number that's not 1 in front of the first element, which is going to be tetra. So tetra phosphorus. I'm sorry, I think I misspelled it. Phosphorus. Okay. Let me erase that. Same thing here. So tetraphosphorus. And tetraphosphorus with 6 oxygen. Okay, so number 6 is a hexa. So hexa oxide. So the prefix in the element name is going to be as one word, P4O6. All right, SO3. Sulfur with 3 oxides is going to be trioxide. Okay, N2O3 dinitrogen trioxide. So 3 and the N2O3. CCl4. This is CCl4, not CCI4. Okay, so it's carbon, tetra, chloride, IF5. Iodine. The number 5 is penta, so pentafluoride. H2O is water. Okay, water it's the name, but we can also use this kind of method. You can try it. Okay, so it's going to be dihydrogen. There's only 1 oxide, so you have to use mono. Should we ignore the mono here? No, the mono has to be there. Okay, mono oxide. Since there are 2 ovals, so you emit 1, so it's going to be monoxide. Okay, keep in mind you only emit the mono for the first element, not for the second element. Okay. All right, so this is how you gonna name or writing formulas. I mean, keep in mind, okay, if you're given a name, for example, dinitrogen trioxide, you have to be able to convert this into formula as well. So this is how we do nomenclature for non-metal combination, which is also to the group of covalent compounds. So this is very important. Covalent bond and covalent compound. There's no charge, no cation, no anion here, and they are all neutral compounds. These are all neutral compounds. Okay, all right.